Hello, everyone. Today is October 20th, and this is episode 16 of our Google Hangouts and podcasts on all things DOCSIS. I'm Brady Volpe, founder of the Volpe firm and Nimble This. With me is John Downey, podcastinator and CMTS technical leader at Cisco Systems. Hey, John, how you doing?
Good. Nice title again.
So you and I were still recovering from the Cable Tech Expo last week in New Orleans, and we're going to bring to our listeners the highlights from the show. So you recovered?
Yes, I'm recovered. I mean, it'll be interesting because, originally we decided to do this earlier. We were going to do it Friday. Then BTR decided to do a kind of an update Thursday. So we're going to get ours before they do.
We got to speak first. Yeah. I mean,
yeah.
That's kind of our, that's the way we roll.
Or people will think we're just stealing from them.
Exactly.
So I do want to do a shout out to your wife who made these nice labels for us.
There we go. So yeah, for people who are just listening to this after the case, we are the #1 DOCSIS show. So we had the #1 DOCSIS podcast. So we had those stickers made up. So if you're seeing mine, #1 DOCSIS podcast.
And I love PNM. So what's funny is like everyone knows Ron Hranick has ribbons going down to his knees. Yeah. And I said, this is one you can't have because you're not part of our podcast.
Yeah, of course. Now he wants to be on our podcast because he needs to get this ribbon for next year.
Exactly. So with that said, I thought it was a great show, good turnout. New Orleans is usually a decent place to have a show. It was weird how they set up the workshops the very first day before the show even started.
The symposium on the first day was, I was really excited about the symposium because, I'm very security conscious. I really am interested in security. So it was a cyber symposium. And I think it's really important that people get educated on cyber symposium. However, cybersecurity. However, we had workshops overlapping, and one of those workshops happened to be your workshop.
So it's funny is like George Salinger's workshop was before mine at 2, and I was told that a lot of people just left the cybersecurity symposium to go start seeing the workshops at 2. His was standing room only.
Yep.
What I did love about how the tracks were set up, I was part of this thing called RF and wireline track. And everyone that was in that track was in the same room, 260. So every time I went to a presentation that I sort of saw that I liked, it was always in room 260 because we're all on the same track. So his was before mine, so I sat in his, standing room only, and then it let out, and mine started at 3:15, and me and an Aris guy were doing the presentation together, and most of those people came right back in again. So it was basically a full house, which surprised me to be the first day of the show before the show even opens up.
Yeah, so I mean, I was also in the cyber security symposium, and I had the same dilemma. I was enjoying the symposium, but I really wanted to see the tracks in room 260 that you're referring to because they're really focused on relevant issues. It's DOCSIS 3.1 and PNM. I mean, that was pretty much the focus of the very first workshop that George Salinger was going to be in, which I went to see, and then yours immediately following. And it was like a mass exodus out of the cyber security symposium.
Yeah, the George's was great because it talked about what Comcast plans to do. And everyone wants to know, what the 800-pound gorilla is going to do. That's Comcast, right? So they're shooting for 24 single-channel QAMs cross-bonded with 96 megahertz of 1K QAM OFDM, DOCSIS 3.1. When you do all the math, and George went through all the math and what's so great about it and blah, 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 and it was good kind of nuts and bolts of DOCSIS 3.1 and an update, and it was about 1.7, 1.8 gigabit per second aggregate speed to offer a 1 gig service. Now, typically, from our point of view, Cisco, myself, we say try to have a 2 gig pipe to offer a 1 gig service. So they're getting close to that. They also said that because they're not going to update their upstream from 5 to 42, they're not going to go 5 to 85 because it's going to be way too expensive. They could stick with 4 ATDMA channels bonding DOCSIS 3.0. And I said, what are you going to offer on the upstream to offer a 1 gig downstream? Typically, people would say 1 gig by 100. But 100 meg from 108 megabit per second aggregate pipe is not a good idea. You're going to starve everybody else. So we think really the industry is going to start pulling that back, reeling that back a little bit to maybe a 1 gig by 50 service or a 1 gig by 60 service. It's still enough for the acknowledgments for downstream TCP, and it's still enough to do, you know, upstream video, upstream best effort, voice, and all that.
Yeah,
so I thought it was a good lead-in.
So you know, George talked about this cross bonding of DOCSIS 3.0 modems and DOCSIS 3.1 modems in a downstream during his presentation. He reiterated it again during the BTR breakfast on Thursday morning. And I really think this is important because it just was not something that I did not read this in the specification to the point where I understood it when I was going through until all the topics of until all the discussion has been around it. But I think this is something really important for listeners to understand who may be thinking about, oh, do I invest in a DOCSIS 3.1 CMTS, or do I just stay the route of DOCSIS 3.0 CMTSs? So, I mean, what cross bonding allows you to do is you're going to have a lot of DOCSIS 3.0 cable modems out there, large space of them, and you'll start buying DOCSIS 3.1 cable modems and deploying those. So cross bonding allows you to have a bunch of downstream SC-QAM channels coming from your DOCSIS 3.1 CMTS, and you could have 16, 32 channels of those out there, and then right beside that you can have your OFDM channels, your OFDM channel, maybe a 24 megahertz block of that running that your DOCSIS 3.1 modems can be connected to. But the bonding, and John, maybe you can explain the bonding a little bit more since you're on the CMTS side.
I mean, you think about it, you get the physical layer, which is the QAMs, which we all know is single channel QAMs, which is what we see with DOCSIS 2.0 and DOCSIS 3.0. But the downstreams are always on. There's no sharing of spectrum. You have to allocate downstream spectrum for 3.0, 2.0, single channel QAMs, and then you have to allocate different spectrum for 3.1. So allocating downstream spectrum that's a hot commodity, right? Trying to find downstream spectrum. So you either do analog reclamation or what we're calling now digital reclamation, going from MPEG-2 to MPEG-4, opening up downstream spectrum, go to 1 gigahertz or 1.218 gigahertz on the downstream. Whatever we need to do to open up some downstream spectrum, throw in a DOCSIS 3.1 channel, could be, the spec says minimum 24, but I don't see anyone doing a 24 megahertz OFDM. It kind of be like, why would I do that? I'd probably do a 96 as a minimum, and then maybe a 192 as the max, and then eventually do multiple OFDM channels. You know, even in our own demo in our booth, we did 2 OFDM blocks of 192 megahertz apiece at 4K QAM, cross-bonded with 32 single-channel QAMs for an aggregate of 4.8 gigabits per second. So, I mean, that's a big pipe that could be shared with 2.0 modems, 3.0 modems, 3.1 modems, a 2 gig service, a 3 gig service, whatever, you know. But you could, the cross bonding allows me to, at a logical layer to say, all right, I can do stripe my traffic across the single channel QAMs and across the OFDM block, and the CMTS knows how to decipher all that and bring it back together. I mean, so it's, I think it's a transitional point. We would do this until we get enough downstream spectrum to offer high speed just from a 3.1 modem. Once we have enough spectrum for maybe a channel or multiple channels, then why would I cross bond with the 3.0 channels? Because then you starve those guys out. You would just basically leave them on their own. And then once you have enough OFDM, you would just say, all right, there's a big enough pipe there for my 3.1 modems, and just let them use that. Right. I see it as a transition, you know?
Okay. Yep. So then we move into your presentation. You had a lot of good points in your presentation.
It's funny, it's like, and I actually thought about this the day before I did the presentation. I told my wife, I said, you know, I've been through so many presentations that you're like just hanging on thinking, all right, just hit the summary. Just give me the summary points. I kind of trust this guy. Let me just see what his summary is. His conclusion. And all the presentations I give, I just talk too much anyway, right?
And you never ever get to your summary slides in your presentation. That's a big problem with you when you just talk a lot.
So as I get up there, the guy in front of me was an Aris guy. He did 15 minutes and done.
Perfect.
I got up there.
Perfect.
I love this guy. I love this guy. He gave me 45 minutes left over. I'm like, I'm going to take it. So I get up there.
45 minutes, but you did take all the time. Yeah.
And I said, I'm going to do something that I've never done before. And I said, I'm going to start at the end of my presentation. I'm going to show you my checklist and my summary closing points, and then I'm going to go back around and try to explain why I came up with those points. And
yeah, which
and
first
it kind of
time
worked out
Expo
well.
history, people actually got to see your summary slides.
And didn't have to read it on their own.
Yeah.
So the other thing I said is, and I didn't mean this as a slight to anyone, but you know as well as I do, you get a lot of these things that people are reading verbatim, their speaker notes. And I was like, I'm not here to read to you. You guys can read on your own. I have a paper that's 29 pages long. It uses Queen's English. So it's not like a PowerPoint presentation with, 6 bullet points and 5 words per bullet point just to like spur me on. Some people are still going against that trend of making slides that are size 5, size 6 font and like 20 sentences on a page and you can't read it anyway. So, I mean, there's a time and place for this stuff. So I hit the summary, hit the checkpoints, went back around, showed my explanation, quickly went over a few slides because I was talking so much anyway. And then I was showing different evolution of 3.1, 12 channels, 24 channels, 32 channels, throwing in OFDM. Why would I do an 85 megahertz upstream versus a 204 megahertz upstream? What could I do with an 85 upstream and then go 1.218 downstream? So I went through those scenarios, and then my last scenario was basically remote PHY. If I can do a remote PHY and put the CMTS physical layer chipset in the node, or for RFOG for that matter, I really believe we can get a 50 dB MER in the downstream and a 40 dB MER in the upstream. You run those numbers, we can run much higher modulation schemes that are available in DOCSIS 3.1. And that's where things are going, node plus 0, remote PHY, and this is further down the road, right? So that's sort of the things I talked about. And then what was interesting is Paul Brooks from Time Warner jumped up and he kind of corrected me, and I'm perfectly fine with that. I like when other people come in and say, your idea here, we could get around this. And I said, you would never do a 204 megahertz upstream because of coax loss and temperature fluctuations and the temperature effect on attenuation. 5 to 42, plus minus 3 dB in range from the modem. I see that all the time, plus or minus 3 dB of modem transmit levels, cold to hot, summer, winter. So we did a test 5 to 85 megahertz. That's you double the upstream. There's a plus 5, minus 5 swing potentially, assuming half-inch cable, 5 spans of cable, yada, yada, yada. So I did that math. I'm like, wow, we don't have enough level left in the modems to, do plus 5, minus 5. And then even if you said minus 5, is that a bad thing? Well, yeah, it is a bad thing because if it gets cold out and there's less attenuation, the modems will hit the CMTS hotter. CMTS will tell the modems to turn their levels down, which is fine, but the noise that comes from the low value taps see less attenuation, so the noise rises up for everybody. So in the cold months, you're going to see a higher noise floor if you did 5 to 85. And I said, well, that's probably going to make us do reverse thermal equalizers, which might handle some of that. On the high side, when modems start maxing out, we have to take that into account. Hopefully a CMTS can adjust. Hopefully the cable modems have a little bit more level. DOCSIS 3.1 actually gives us a little bit more power level versus 3.0. The Cable Labs ECN for extended upstream power, maybe I could put those off of high value taps. So there's some things I can do on the high side. And I said, I just did that math for 85. What if we go to 204? Like, oh my God, 5
it's
to
going to be like 12 dB, plus or minus 12 dB or something. It's going to be pretty bad. It's going to be ugly.
Think about it.
And now you're just going to have modems going offline because they can't transmit in the summer, and in the wintertime, you're going to have god awful SNR.
Yeah. So I said 204 makes sense with less coax. It gets rid of the temperature fluctuations of coax if there's no coax.
Right.
So node plus 0, RFOG. Remote PHY with just a little bit of coax. And then Paul came up and he informed me, because I said, we don't have upstream AGC in the amplifiers, and how would you have a pilot? Because upstream is bursty. Would you have to put a pilot carrier at the end of line of every end of line somehow? And he came up and he says, there's an idea, and I totally agree with it. It's kind of cool. I don't know if it'll ever happen. If you have a downstream AGC already compensating for temperature fluctuations at say 631.25 megahertz, channel 61, or whatever that frequency, it's like 439.25, I don't know. Say you have a downstream AGC circuitry looking at temperature fluctuations, because it's all math and you know the coax loss and the mathematics behind it, you can say if I lost 3 dB of signal at 631 megahertz at 42 or 204, maybe I need to adjust an AGC circuitry by 1.5 dB.
Right.
You could run an upstream AGC based on the downstream AGC circuitry.
And it makes sense. You have some scaling factor. You're going to have to put possibly what we call a pin diode circuit, which is, you know, some sort of an attenuator circuit in the return path. And in order to go to 85 megahertz or 204 megahertz, you have to change out that module anyhow. So we would be able to put that additional circuitry in there. So I think Paul's idea is actually pretty good. It's pretty valid. I've done a lot of work on AGC circuitry and pin diode and stuff before. So the circuitry is so close to the return path anyhow, running that line from the AGC down to the return path and adding that additional circuitry in there is very valid. It would now, it's just now a matter of convincing the vendors to put that circuitry in there.
Yeah, that, and is there a demand for it if only one MSO doesn't plan to do node plus say one? Is this really a stepping stone to say, hey, we could change out our modules and not change our architecture? We have node plus 5 in most of the US. So maybe we'll stick with node plus 5 and do a mid split. So then it becomes, is that really where we're going? Or would we end up redoing the whole architecture anyway to do remote PHY or node plus 1? And if it's node plus 1, maybe we still do it. I don't know. You know, would we even have a downstream AGC if we're node plus 1?
Yeah, I think there's a lot of things we have to see, because if we get to the point where we can put I think reverse PHY, if we get it out there, remote PHY, that gives us the opportunity to really expand the return. And if we have that expanded return, because I think we have to have remote PHY in order to expand return to 85, 204 megahertz. Otherwise, we won't be able to send back a lot of good quality signal without getting rid of the analog laser. So remote PHY is key to that.
Yeah. And the 85 or 204 upstream is all predicated on the downstream set-top boxes not being hard set for their legacy control channel. Right now, we're very limited because of legacy set-top boxes. Some of them are frequency agile. Some DTAs are set at 75 megahertz. Well, I can't even do an 85 upstream because of that.
Yeah, and I think, you know, we have like Comcast just announced that they're going all in on IP video. So when they're going to be a major driver for that, and going to all IP video gives us the opportunity where we'll get the scale in order to change out, having someone who will give us the ability to change out set-top boxes, like the X1 platform is one example for that. So getting rid of those set-top boxes is going to be key. An X1 platform, all the new set-top boxes that we see coming out from non-traditional vendors is very clear. I think we're seeing a tremendous drop in the current volume we know that set-top boxes are going away. They're dropping off.
Yeah.
There's a lot of
we could say that and say, oh yeah, there's only 2 million left, but it's still 2 million.
Well, yeah. The challenge is what's deployed already in customer houses. We have to replace those, and that is a huge hurdle to overcome.
I thought it was interesting. Also, Tony Warner talked at the Cable Labs DOCSIS 3.1 interop, and he says, one of the leading things that we're seeing is no one really wires into their modem anymore. Everyone's wireless through their house. So upgrading the modem to a 3.1 modem with better wireless capability is a big thing for them as well.
Mm-hmm, absolutely.
Now they might be able to get more speed through the wireless because the wireless is better than what some of the gigabit Ethernet ports on the modem itself. I mean, the demo we did in our booth is we had 2 modems, DOCSIS 3.1 capable modems, with 4 1 gig E ports on the back. So we basically had to stripe the traffic or run the traffic across the multiple gig E ports. A gig E port will never get you more than, say, 970 megabits per second. It'll never give you 1 gig just because it's layer 2, layer 3, and all that, the overhead. So until we get, a 100 gig E port on a 3.1 modem and CPE that can actually hook up to that, which no one's PC has 100 gig E ports, no one that I know of. But if I do it through wireless and I can get more than 1 gig on a wireless, then maybe multiple devices could just hook up wirelessly anyway and do more than 1 gig or do 1 gig or whatever. So, I mean, there's kind of interesting ideas about it's not just going to 3.1 more speed, but also the CPE gives us more flexibility. With your PNM stuff, the CPE gives us more PNM opportunities as well, right?
Right. So yeah, so that goes into my presentation, which was the next day on Wednesday. It was on PNM. There, PNM was another huge topic. It was like DOCSIS 3.1 and PNM were huge topics at this show. Which it was 3 years ago that we released our Nimble This PNM platform at SCTE Expo, and no one knew what PNM was. This year was the year there was like 3 workshops on PNM displays everywhere at SCTE Expo. So this year my PNM presentation wasn't on, oh, here's this crazy PNM technology. I didn't have to educate people on pre-EQ taps, pre-equalization, and stuff like that. We did a raise of hands, how many people are using PNM, and nearly every operator in the room raised their hand. So people are already using PNM, either from Nimble This or they've developed their own in-house solution. So that was awesome. The workshop I did was on how to operationalize PNM in your organization, how to set up training programs. We had a thing on PNM gurus, getting someone within the organization that's an expert on PNM and building on successes in the organization to push that back into the PNM organization. And then also setting up KPIs, ways of measuring the success of PNM, like reduced truck rolls, reduced CSR calls, and how that's reducing CapEx and OpEx throughout your organization. So you're actually demonstrating the return on investment that PNM, proactive network maintenance, is helping your organization, so that the next year when budget time comes up, you can further justify reinvesting in more PNM development, reinvesting in more PNM tools, in further resources that you're going to allocate to proactive activities. And so that again, it was standing room only for a PNM presentation, and it went over really well. I had a bunch of people come up and say, yeah, thanks, we didn't think about tracking the metrics, so that we can go back to our CFO and ask for more funding into our PNM product afterwards. So fantastic standing room presentation in room 260, just like you were saying the day before. Yeah. So this wireline and RF track was a fantastic track with the SCTE workshops.
I agree. I think you even coined the term PNM champion.
Yes, PNM champion, and so then the SCTE came up afterwards, and they want to develop a complete track and training workshop, and we're going to work with them to help talk about that, because we have so much experience now working with different cable operators on developing their own internal PNM champions. We want to work with the SCTE so that cable operators who don't already have this experience can work with us to help develop their own internal PNM champions. Because that is one of the key challenges. You get PNM inside, it's like any test tool. If you don't use it, you don't have someone knowledgeable on how to use it, it's going to sit in a corner and collect dust. So that was the big focus, is in how to operationalize PNM once you have it in the organization.
I liked your feedback also about identifying problems that you found with PNM and using that as a suppository?
Repository. I know you like the suppositories, but we like to think of it as repository.
Gotta keep it light around here, man. Gotta keep it light.
No, that is absolutely key, because you find amazing things with PNM. And I had one of the pictures up there with this really amazing damaged piece of cable. I mean, if you look at this cable and you say, my gosh, every modem and set-top box should be offline downstream of the cable, but it wasn't. But there were some key signatures that we see using the PNM tool, and so you put that into the repository. So the next time when someone sees that particular impairment using the PNM tool, they say, okay, I know what to look for. If they say group delay, they see group delay, they can say, okay, this is what group delay looks like using the tool. And then, there's a bunch of signatures that you can have, and that's all that pulls back into your internal training tool. Your PNM champion knows what to look for, and then it's just an educational process.
Yeah, I call it like fingerprinting. You're making different fingerprints or signatures for different types of problems.
Absolutely.
Like you even said it, an if-then statement. If you have this, then you might have this. It's just a simple logical statement. I think everything was great there. Even the co-presenter in your workshop, Mr. Hunter from
David Hunter of Cable Labs. Great.
You could tell he was, more of a lab guy because you could tell how excited he was to be able to get out in the field and actually see some of the stuff at Armstrong in the middle of winter outside Pittsburgh last year.
Yeah, they said doing their work, it was just freezing. I was like, oh yeah, I know. You and I both know Pennsylvania.
Yeah, no kidding. And but what I thought was interesting is taking pre-equalization taps and looking at it a different way. And it wasn't just looking at the signature or looking at the taps; it was looking at the taps over time. So if you can look at, say, one modem and the pre-equalization taps are fluctuating quite a bit, they were able to correlate that with maybe impulse noise, or not. Actually, it wasn't impulse noise; it was intermittent connectivity.
Intermittent connectivity. So you're looking. I mean, we're looking at two things there. We're looking at the cable modem transmit power varying, and then we're looking at the non-main tap energy varying, which are as you say, it's the cable modem pre-equalizer taps. And if you get a positive correlation between the non-main tap energy varying and the cable modem transmit power varying, then we say this is a cable modem that has a very high probability of letting noise ingress into the plant. And we can see, as he said, 7 out of the 10 modems, they went in that cold Pennsylvania, Pittsburgh winter to look at. They found that there was a huge amount of noise coming from.
Well, let's do this. Let's run some numbers. He threw this up there: 126,000 modems. He narrowed it down to 500. Further narrowed it down to 40. They only went to 7 sites, but he narrowed that 126,000 down to 500 that were showing the same type of signature down to 40 modems to actually go check out.
Yes. So it's about 1%. 1 to 2% of the modems that we see are intermittent modems, because we have, Cable Labs developed it. This algorithm, David Hunter did a lot of the work on it, and we put the same feature in the NimbleThis PNM tool, and we call it the intermittent modem report. So we do this effectively the same thing. We correlate cable modem transmit power to non-main tap energy, and then we put up these modems, they're called golden nuggets as they so call them. But we see about the same thing. About 1%, 1 to 2% of the modems have this really nice correlation factor. And then you go look at the modems and same thing. It's a high percentage of them are really leaking a lot of ingress noise into the plant because they have a loose connector on the back of the cable modem or somewhere in the house or even at the ground block. And that's just letting all kinds of noise come back into the return path.
I just think it's cool that we're exploiting this even more and finding new ways to, it might be reactive and proactive at the same time, right? I mean,
Yes.
You're fixing a problem, or you're fixing a problem that's not quite bad enough because pre-EQ is masking it.
Yeah, I mean, so PNM used to be just looking at the cable modem pre-equalizer data. And now we just keep expanding it to say, how much can we do just with a cable modem and the CMTS to look at things, find like intermittent modems, look at upstream spectrum analysis, look at downstream spectrum analysis, all using stuff the cable operator already owns, the cable modem and CMTS. So it's just awesome. We keep finding more and more power in devices that are just sitting out there pushing customer traffic back and forth.
Yeah, I agree. It was good. I even brought up, they were talking about DOCSIS 3.1, some of the features, and I brought up during the Q&A, I said, I even utilized this feature already with a 3.1 modem, the reverse sweep feature. Basically, the modem itself can sweep through the whole spectrum. Now, the new 3.1 modems have adjustable or programmable diplex filters. So that way I can set up for 42, 65, 85, 204. What I found with a couple already is I was doing 8-channel upstream bonding, and one upstream channel was bad MER, went into upstream bonding partial mode, didn't know what was going on, used the reverse sweep functionality of the modem itself to sweep through the spectrum. The modem's built-in filter was cutting off right at 42, like a suck out, and back up again to go to 85. So it's like 2 filters were turning on at the same time and then sucking out right at the cutoff point at 42.
Yeah, so how cool is that? I mean, there's a bug in the modem, right? It's a diplex filter not working right, but we can use the built-in test capabilities to sweep. We're not sending technicians out to sweep. You're sitting remotely saying, I'm going to sweep the plant using the built-in test functionalities of the cable modem and the CMTS.
And what's funny is, if you went out to sweep, you wouldn't have found a problem, because the problem was in the modem.
Yes.
You know?
Yeah, we're right, because when you sweep, you're only sweeping from where you have the sweep injection, normally close to the laser, or to where you're at. You can't sweep from the inside of the modem to the CMTS. With DOCSIS 3.1, we can do that, and we can do that in the downstream too. So it's so awesome. I'm so excited about what we're going to have.
It's like finding a modem like that and knowing it's a certain brand or firmware. I could easily just take maybe that MAC address, put it in a DOCSIS restricted load balance group, and steer it to a 4-channel bonding group. Yes. And not even let it do 8-channel, you know, or whatever.
Say, we're going to put it there until we get that firmware upgraded. We fixed the problem.
That's cool. So the other thing I brought up, I said, you were on the panel, I said, do you guys see any place where pre-EQ would be a bad thing? And, you know, everyone hem-hawed around a little bit. And I said, all right, let me give you, it was a sort of rhetorical question. It was.
Well, you and I knew the answer because we tested it before. And I said, well, pre-EQ sometimes can get a little flaky when impulse noise is around. And I said, well, if I have an upstream channel below 20 megahertz, I'm not going to have group delay issues typically. I can still have micro reflection issues easily. So pre-EQ is still functional and good for any frequency for micro reflections. But when you get below 20 megahertz and there's known impulse noise, could it be a detriment? Could pre-EQ be worse because the impulse noise is thrown off the pre-EQ? Would it be better not to turn on pre-EQ? And my thinking there was, I have a lot of systems doing a quarantine channel that might be 1.6 megahertz wide, and then 4 ATDMA channels for bonding. So the quarantine channel is for DOCSIS 1X modems or DSG boxes. You know, I don't need the speed, I just need connectivity. That's a type of channel where I might say pre-EQ is not really going to give me that much, or it could hinder me if that channel is in an impulse noise environment. And that's where I'm kind of struggling is, should I turn it on or should I turn it off? If it's a 2.0 modem or 2.0 DSG box, well, then maybe I'll probably turn it on. If it was 1.1 and only 8-tap equalizer, I probably wouldn't bother. What do you think? Yeah, no, absolutely. So, and our recommendation was, I mean, pre-equalization just gives so much benefit to the return. I would never recommend disabling it. But as what we've recommended before is increase the preamble and turn on interleaving. I don't think it's, even though I know there's impulse noise, more impulse noise at low frequencies, I've seen impulse noise go all through the return path, even at higher frequencies. So I don't want to turn off pre-equalization at low frequencies just because there's impulse noise there. I'd rather deal with the risk of the impulse noise coming in and just do some of the things that we recommend to do to counteract the impulse noise, which is longer preamble length and interleaving.
Yeah, I agree. I think also it would be one of those things where you monitor the modems, and if their pre-equalization is very active and they're the only ones being active at that frequency, then that might drive your decision. Like maybe it's looking like pre-equalization taps are fluctuating, like intermittent connectivity, and it turns out the impulse noise is making the taps adjust more. So it's kind of a false positive maybe.
Yeah, so I mean, after 3 years of production PNM work and a year and a half before that of field trials in PNM, I still have not seen modems that, you know, like you have a large say body of modems that were negatively impacted due to impulse noise over any extended period of time. Anything that, you know, say modems fluctuating around from red to green, we always found that in almost every case that was due to intermittent connections. Now, say the intermittent connections were due to maybe that was causing some flapping because from red to green of the pre-equalizer, maybe that was letting ingress noise come in. That's fine.
How many channels were at 15 megahertz and below?
So I mean, well, at 15 megahertz, I would say no channel. I don't think we have channels at 15 megahertz and below. So the majority of the channels are always right around 20 or, you know, right around 20 megahertz.
Of course.
But the point is, well, I've seen channels of 20 megahertz that are flapping. Those are showing up in our intermittent modem reports. And those are the ones where we're seeing them moving, and those show up on the intermittent modem report, and that's saying, hey, we have ingress coming into our plant. So to the point is, those are modems. We see them moving around. We can actually use, possibly in this case, the benefit of the impulse noise causing those pre-equalizers to move around as showing up as intermittent modems. And this points us to, hey, there's a leak in the plant here. There's noise coming in the plant here. So in this case, that's actually benefiting us, the fact that impulse noise is causing the equalizers to move around.
But this brings up another point of, you never rely on one thing to be the gospel. This is why we look at everything, right?
Yes.
This is why we look at the CMTS, correctable, uncorrectable FEC. We look at the CMTS MER. We look at the CMTS CNR. We look at the modems, at the modem, the downstream levels, all that stuff, the pre-equalization tests. We look at everything, right? And I tell people, when you have impulse noise, normally on the CMTS, for that upstream channel, and maybe that modem specifically, you have a lot of uncorrectable FEC and not as much correctable.
Yes.
Because when you have impulse noise, the forward error correction doesn't work that well, so you don't get any correctable. So if I see uncorrectable FEC incrementing more than correctable, the first thing I think is impulse noise. Then I look at a spectrum analyzer. Then I slow down the sweep speed. I turn on peak hold, and then I see impulse noise, and I verify it, right? So there's a lot of other things we look at.
Absolutely. That's a very good point to do. Take a holistic approach to it. Have a lot, more than just one tool in your toolbox, and you'll get to the bottom of the problem.
I'm looking at my notes.
Yeah.
I have a bunch of things which brought up a good point, because I asked about, a channel being below 15 megahertz, which you normally don't see, and I don't see it that often either. I mean, we're running out of spectrum, so we're trying to do 4 ATDMA with maybe a 1.6, so that's at like 15 to 18 megahertz. There was one vendor I ran into that's making a filter that I've always promoted this. How do I get rid of impulse noise and crap below 20 megahertz? Assuming I don't need that spectrum. Assuming I don't have old set-top boxes at 8 megahertz, 11 megahertz, or status monitoring or whatever, most of that noise, if I can filter it out at the node, I can eliminate a lot of potential laser clipping, because that's where a lot of the energy is coming in, below, say, 18 megahertz. So this company is making now, on a JXP pad footprint, a filter that I can plug right into the node on a JXP pad footprint. So really small, like 60 dB of rejection. I was like, wow, that's pretty impressive to be on such a small footprint and be able to plug into maybe the reverse pad location of a node.
Yes.
So now all of a sudden I can filter that. No, I'm not worried about the amplifiers. They have good dynamic range. It's the node. Analog laser links are still my Achilles heel.
So I love the idea. I love the concept, because we're putting them in. We're getting rid of the noise. However, like we've seen in the past with the RCOM filters, it's great. We get rid of that noise, and then unfortunately we forget that we put that filter in, and we think, awesome, we have a really clean spot below 20 megahertz. We can drop a DOCSIS channel in there, or we can push a DOCSIS channel up close to there, and we have problems. And so that becomes the challenge. We just have to document when we use something like that. We put it in, and where did we put it in? Because then when we do want to move DOCSIS down to lower frequencies, we have to remember why that frequency is so clean.
My visual aid there is, if it's too good to be true, then there's something else going on.
It is, yeah.
It's too good to be true. Yeah, if it's that clean and something's not going, you're not looking at it properly, or something's filtering it out. The other thing I said is, someone came up to me and said, if I have, and I told them the Cisco CMTS has this feature called direct load, where if a cable modem's MER drops, its upstream MER drops by more than 3 dB in a 15-second station maintenance window, we assume the pre-equalization is kind of screwed up. So we send a direct load to the modem to reset it. So he's looking at an idea of turning off pre-EQ on a modem to check to see sort of what the MER would be without pre-EQ and stuff like that. I said, the bad thing is, even if you go into the CMTS and say, equalizer coefficient exclude this MAC address, the CMTS will quit sending it pre-equalization updates. The modem that has pre-EQ on will retain those pre-equalization information maybe forever, because it's not getting updates from the CMTS. I said, so you either have to power cycle the modem to kind of clean it out, or maybe we can use this direct load, like a test command, to tell the modem, clean yourself out, go back to scratch. now let's see, well, it might even go offline because the pre-EQ might help keep it online in the first place. But we want to see if that modem's MER is really bad without pre-EQ. Kind of like saying, what is the MER with and without pre-EQ? And it was, I think, his way of kind of testing the modem. And personally, I think that maybe you guys can do this. Can you take the modem's current MER at the CMTS and extrapolate the pre-EQ taps from the modems and come up with an MER of what it would be without pre-EQ?
Yeah, so actually, and actually, we can do that. We can back it out. It's not something that we currently do in software, but I have a MATLAB algorithm that goes back and says, you know, we know how good it is with pre-equalization on. This is what it would be without. So, the concept you're saying, you know, is wipe the pre-EQ coefficients using your direct load. But if you're using the PNM application, we could actually show what the value is. We could give you an estimate of what the upstream SNR or MER rather would be with pre-EQ, if pre-EQ were not enabled.
Yeah. Almost like saying, how hard is it really working?
Yeah, because we know exactly how hard the pre-EQ is working, and we can give you an SNR estimate. Actually, yeah, we just don't display the we know what the SNR estimate is. Or MER is. We just don't display the MER, which is with the EQ off, and what it would be.
All right. What else did you see while you're walking around?
So, so a lot of test equipment vendors. The big thing is getting the new DOCSIS 3.1 chipsets in. That was a big focus. And I think they're coming out with really big meters because the DOCSIS 3.1 chipsets are taking up a lot of power. And while to me, because I'm so focused on PNM, I'm more interested in the vendors that are coming out with modem solutions that are using like iPhones and stuff, because they can have a modem that gives you full band capture, that does DOCSIS 3.1, that looks at the upstream, that has things like that allows you to do sweep. Basically everything that you would pay for in a really expensive handheld meter, but they're doing this with a kind of field hardened cable modem and battery pack at an extremely low cost price, because they're building it on top of an OEM modem solution. Those I thought were really cool. I did look at some companies that were still just saying, well, we think it's a little early for DOCSIS 3.1. They're going to look at that once the chipsets come out later. Company we talked about, Divisor, they have I love this little meter that they gave, that they're letting me borrow for a little while. It's the Divisor DS2800, and this thing, you know, I love the AT2500. I used to work at Sunrise. It's now a VX meter, but this thing is so similar to the AT2500, except it goes higher in frequency. It's a lot lighter to carry around. It has a DOCSIS 3.0 chipset in it that I think it does, is it 16x4 or 20? It has a higher DOCSIS 3.0 chipset. But other things, I mean, it does auto detection between 64 and 64 QAM. It auto detects the channel plan for you, so you don't have to program that all in. It's a really nice spectrum analyzer, but it also does some cool things in the upstream where it sees, like we do with PNM using the CMTS, it also sees ingress under the QAM. So, for cable operators who are looking to get a new head-end spectrum analyzer, this is kind of like a really nice spectrum analyzer, and I think it's like 4K or something compared to the much more expensive one. So I like it.
The upstream go down to the upstream spectrum? Is it 5 to 85? Is it 0.5 to 85?
I think it's like 0.5. Yeah, it's 0.5, and but it goes to, I think it's a 3 gig spectrum analyzer, so it goes a lot higher in frequency. It's a really nice spectrum analyzer, and the price is right on it, so that makes it.
What's the connectors? Are just F connectors?
There's 2 F connectors on them, because it also gives you, if you've ever used the upstream signal generator toolkit where you inject a signal in the upstream, and like a 16 QAM or 64 QAM to proofs to see what the channel looks like. I mean, granted, we can do that now with PNM, just using a cable modem and sending that back to the CMTS. But sometimes it's nice to have a meter like this, and I'm just stuck on the cost of it because it's so inexpensive.
Yeah, nice. And yeah, I like the fact it goes below 5 megahertz just so I can see AM radio noise and shortwave radio at 3.5 or WWV, the worldwide clock or whatever, at 2.5. And so, I mean, there's still ingress I see coming in that causes laser clipping. And normally I don't see it coming in. Even if it comes in, it drops, the diplex filter amplifiers will block it out, but I've seen it come in at the node itself. Sometimes I think it might be coming through the power insertion port of nodes and not really the power inserter that you really should use on the coax to help give you extra RF choking.
Right.
You know? But it's just another issue we've seen, right? If people go to digital lasers, then we wouldn't have this problem of analog laser clipping. Yep. Then we'd have D to A clipping, analog to digital clipping. But it's where things are going, right? I wanted to point out, I think another thing was I saw there was a sound bite for the breakfast panel that you did.
Yeah, so there was a BTR breakfast on Thursday morning, and that was live streamed. It's out there. If you look on BTR, you can watch it's recorded, on like VOD, so you can watch at no cost that whole breakfast interview that you're talking about.
So I mean, it was you, George Salinger, I think, Ron Rannick, and who else? Someone else.
Blau from Cable Labs, and Mike from SCTE. His name is escaping me at this moment. So
yeah. So everyone was reporting, and the press was writing how everyone was praising the virtues of DOCSIS 3.1 and kind of like the next coming of the savior of the world.
Yeah, it was basically a DOCSIS 3.1 and PNM conversation, and
but it was
lines and
it was everyone was saying, yeah, this much speed we can get, and I know what we're trying to do as an industry is say this is our way of ubiquitously getting giggy speeds to all of our customers. Ubiquitous meaning everywhere. Not cherry picking GPON solutions for business services over DOCSIS or small business, whatever you want to call it.
Well, I mean, questions did come up about like, well, why not just go to PON versus DOCSIS 3.1, and we kind of set the reality of, well, you can't just rip all the coax out of the ground and replace it with fiber overnight. It's just not practical. It's not cost effective.
Yeah, especially when you're a publicly traded company.
Exactly.
So I saw these write-ups about blah, blah, blah. And then Ron Rannick, who is a realist and talks about technology and complexity, and same as myself, I would say the same thing. Here's some things we need to look out for, in the trenches. Here's what we need to look out for. And he talked about the complexities will require people to understand how things work, blah, blah, blah. So in the write-up I saw from a press company or magazine that's probably not very cable-centric or likes us for some reason, the cable industry, they said Cisco exec, which Ron is not a Cisco exec, Cisco exec says the complexities of DOCSIS 3.1, it's like a soundbite on the negativity. And I was like, wow, they really misconstrued, I think, some of the what we're trying to promote here, and they just jumped on it. So I don't know if you saw that or not, but it just caught me by surprise of them trying to make more out of it than what it was.
Yeah, so this is coming from, I think the publication is Fierce Cable, and I'm not sure what's going on there, but they definitely seem to not be the way that they're researching and covering topics in the cable industry. As you said, it doesn't seem to be very cable friendly lately. And I think they also, I've seen some articles they've had like on regarding the SCTE right before Expo and stuff. It was really very negative SCTE. So I know that they're not kind of like with a regular press corps in the press rooms where like BTR is and CED and stuff like that. So yeah, I don't know. Take it with a grain of sand. Yeah, you just
not with a grain of salt, but with a grain of sand. All
yeah,
right.
I like salt. I put salt in my food. I don't put sand in my food.
So I thought that was kind of interesting, and I know you were there. I left Thursday night. I think your talk was Thursday morning. Too early for me to get up.
Yeah.
Sorry.
No, the BTR
Sorry,
breakfast panel is great. Tim Herms, the owner of BTR, announced right at the beginning of the breakfast that he's retiring, which in the cable industry just means that you're going to work slightly less and can consult. But he's like handing the reins over to the guy that was moderating the panel. I think that's how it's working, and he'll still be involved, I think, to some extent, but he's a little emotion over and stuff. So he's a great guy, and it was a very nice kickoff to the breakfast panel, and the panel went great. It was packed room. They filled it up, and so that's they live streamed it because the room couldn't accommodate anyone, but it was a great breakfast, great panel, really interactive. A lot of good topics. And the one thing they were trying to nail George down on were timelines. And it was really funny because George finally looked at the moderator and was like, how many more ways can you ask me this question? And the guy's like, I don't know. I'll get back to you on that. So it was awesome. It was a great panel.
Well, I mean, I think I hit most of my key points.
Yeah. The one thing I wanted to also cover was on the floor, we did a number of demos as well. I did like PNM demos and stuff like that that were always well attended, but none as well as the demo done by Comcast, specifically Larry Welcott and his team at the Cable Labs booth. So we kind of promoted that in my presentation, that he was going to be doing it, I think that day or the next day at, it was like 3 or 4 o'clock. And it was just, it was just absolutely packed. I have pictures. There was a mob of people around the demo that Larry and his team did. They were using the full band capture capability in the modems. They had identified a customer's house that had a suck out in it. And they had a technician at the customer's house that was, there, so we could see the suck out. It was really visible. This is live.
Right?
This was live. So they found the suck out. The technician's at the house. They called the technician, and they're like, "Well, we're going to wait for the technician to find out where the problem is." And so it was about 10 minutes. Larry's going through some other slides, explaining stuff. We get a call back from the technician. He's like, "I think I found the problem," and they rescanned the modem, did another full band capture to get the data back using SNMP over the modem, and the suck out's completely gone. The whole response to the modem looks so much better. And, I think for people who maybe don't have these tools or haven't seen this before, it was just like, wow, that is totally amazing to be able to.
What would make this even better? Make the technician wear a GoPro.
Yes. So you can see him like going through and taking connectors apart and putting it back on. Live video feedback. Yeah, that would be better. So. and that might be where we're heading as the industry. You think about it, when they're putting cameras on police and stuff. We can put cameras on technicians. What a great training way. What a great way to training videos and stuff. So you have a technician who really knows how to do stuff. And
like you said, you got a PNM champion following him along and saying, well, according to the response I'm seeing, and you're showing me the coax and stuff, it's probably between the ground block and the modem, maybe at the splitter or whatever. So maybe that guy actually is kind of training him as he goes.
Yes. I mean, we're changing so much as an industry where the only way you'd be able to see something like that before would be to take, if you think, I think loyal order of the 704, they're looking at this and saying, oh my gosh, if I had that equipment, this guy's carrying a big box that had none of this around. And now we can sit in an office at a desk and say, I have a suck out in this subscriber's home, and are all the subscribers off of this line extender have suck out. So it's not in the home. It must be at the line extender. I mean, it's mind blowing. It's so exciting to see this stuff happening. And so when Larry was giving this demo, those of us have seen it like, oh yeah, I've seen this a dozen times. Those of us who haven't, it's just like, this is awesome. I got to get me some of this. That was a great demo that they did. Yeah,
I agree.
That was cool. So, yeah. So I think that was the show in summary, as seen by me and you. And it's awesome to have seen how DOCSIS 3.1 has come together so rapidly from the spec to hardware that's working, and I think George Salinger reiterated that a number of times. It's awesome to see how PNM has come together from, some tools that we introduced just a few years ago that people were like, what is this PNM mumbo jumbo, to now where everyone's like, I got PNM, or I got to get me some of that PNM. So I'm super excited about that. And it was a great show. I had a great time. I was super exhausted at the end, and glad to get home and sleep in my bed. So.
Me too. Not in your bed, though. I wasn't living in your bed.
Believe me, man, I was glad you were in my bed, too.
So it's funny, I have to throw out this one word. As me and your wife, Mia, were watching, the demonstrations, you were right beside us, and one was yours, the workshops. And the word of the day was riveting. Sometimes it was tongue-in-cheek. Other times it actually was riveting, but other times it was just tongue-in-cheek, riveting.
I know what presentation you're talking about.
Oh, God. Okay, so it was a good wrap-up. I mean, it was a good show. And then you and I can talk about what we're going to do for the next one, right? Next Google Hangout.
Sounds good. John, as always, it was a pleasure. Take care and have a good one.
You too. All right, we'll see you.